All right, so I'll do that at the end. Let me just go ahead and get right on into notes. One of the things that I had mentioned is that you don't have to print notes, but you're probably going to find that it's much easier if you do print notes, because if you don't print notes, you're going to be writing a lot. All right, so just so that you know, it probably is easier. The embedded question that I had in the video was, are these sets exactly alike? And let's see, it would have been, help me out here. I think it was, oh, hang on, I ran an update. I think it was the set that was from 10 to 12. Was that the one that, was there two of them? Or is it only that pair?
No, it was just the 10 to 12 of, it was the set builder notation one, the listing notation one.
Those, oh, set builder and listing?
Yeah.
Gotcha. So this one here.
Yeah.
Okay. All right, good. So question is then, are they the same set? That was the question that I asked you in the video. You should have taken some time to answer that. So are they the same set, yes or no? And by the way, when I ask questions, I'm always going to follow up with why. Okay, so you don't get the chance to just eeny, miny, mo, it's a yes or a no. It's going to be, okay, why do you think that? All right, so are they the same set?
Yes.
Okay, why?
All notations are the same because listing notation shows like all the values, and in the set builder notation, it has the it says 10 is less than or equal to X. So yeah, I mean that means 10 is going to be in it. Part of the values, and then it says the same thing for 12, so it would be 10, 11, and 12.
Okay. So that you, Reed? Was that who that was? Okay. Yeah. So Reed feels like they are the same thing. All right. Anybody who wants to agree or disagree with Reed?
I agreed with it.
Okay. For the same reason?
For the same reason, because I saw the 10 and 12, and I was like, well, only 10 between 10 and 12 is 11.
Okay. All right. What else do you guys think? Agree? Disagree? Everybody wants to agree.
Yes.
Okay. You want to agree as well? Who was that? Was that Brianna?
Brianna.
Am I saying your name right? Is it Brianna or Brianna?
Brianna.
Brianna. Okay, I'll try to remember that, Brianna. So you agree as well, Brianna?
I do.
Okay. Is there anybody who disagrees?
I have a question.
What's your question?
Where is it? I can't find it anywhere.
What's it?
Like what?
What?
The assignment.
The assignments?
Like what y'all are talking about right now. I can't find it anywhere.
Oh, it's under course notes in my lab.
Oh.
There was a video on that. Yeah, it's under course notes on the left tab. Course notes and videos. You open that up, then there's course notes for printing. And it's in there. All of the notes for the whole entire semester. Justin? Uh-huh. Right, but there's an or in there. It is less than. So it's one of those. Yeah, still agrees? All right, so I still don't have anybody that disagrees. Now, either that means that everybody agrees or somebody does disagree, but you're too scared to say that you disagree. Let me say this, guys. Okay, let me just, it's a little early to be taking a rabbit trail, but I'm going to take a rabbit trail. Okay? This math classroom is a good place for making mistakes. So let me ask, is it better to make a mistake in class in front of everybody, or is it better to make a mistake on the test? Why in class, even though it's embarrassing because it's in front of everybody? Right, because you can get corrected and then you can get it right. Why is it worse to get it wrong, to make a mistake on the test? It affects your grade. Being a little bit embarrassed doesn't affect your grade. It might affect your ego a little bit, but it doesn't affect your grade. Okay? I need you to understand from the start. I like when students make mistakes in class. Does that make me a horrible person? You might think so, but listen, if you're willing to make a mistake out loud in class, you're actually gonna learn something. And I'm all about what you're learning. Okay? Listen, if you knew all the Math 110 stuff, you would not be in here. You're in here because you don't know. And it's okay to admit that you don't know, right? So this is an okay place to make a mistake. If you disagree and you're the only person out of 20-some people who disagrees with every other person in the room, that's okay. It's all right, okay? So, and by the way, you're gonna see me make mistakes, okay? And I'm gonna willingly make mistakes in front of you and be willing to admit that, okay? There is nothing wrong with mistakes. That's where learning is actually taking place. So actually, what we should be doing is we should be embracing mistakes. We should be excited when we make a mistake because that means we're making a learning pathway in our brain. Okay, so one last time, anybody disagree with what everybody who's verbalized says? Are these sets the same thing? Okay, everybody's wrong. They are not the same thing. They are not the same thing. What about the number 10.1? Is 10.1 in the listing notation? Is 10.1 here in this listing notation? No, it's not. Is 10.1 greater than 10 but smaller than 12? So is it in this set up here? Absolutely it is. How many pieces or how many elements are in this set up here? No, don't answer that question. How many pieces are in this set down here? There's 3. How many are in this one up here? Now you can answer that one. There's an infinite number of them. There's an infinite number. They are not the same set. The majority of the time in Math 110, we're gonna use interval and set builder notation. Those are the 2 most common ones that we're gonna use. The only time that we're gonna use listing notation is when there's a small amount of pieces that I can just list them out. But I mean, can you imagine me telling you, you gotta list out all of these? We'd be here for a while. Like till eternity, and we still wouldn't be done because there's an infinite number of numbers in there. Okay, so no, they are not the same thing. All right, as far as the little chart here that you would have filled out for your extra credit, interval notation is going to use the brackets. Set builder does not, listing does not, graphing does. For the curly Q brackets, those are used in listing notation, as we showed here. They're also used in set builder notation. For the X, no, I'm not going to say it. What's that bar mean? Such that. For the X, such that, that's in the set builder notation and only in the set builder notation. Less than and equal to, less than, those are only in set builder. For just a few pieces, we would use our listing notation, and for an infinite number, we would use these 3. You could probably also use graphing for a few pieces. Graphing could be done with either one of those. All right. Okay, so then in the video, I walked you through relation, domain, range, function, and all of that stuff. So folks, I'm not going to repeat what I've done in a video. If you spent the time to watch my video, first of all, I apologize. You have to listen to me at night as well as during class time. But if you spent the time, I'm not going to waste your time coming to class to repeat what I did on the video. You gave me your time at night to do that. So I'm not gonna waste your time in class by repeating it, okay? So let's take another small rabbit trail on this one. Has anybody recently learned how to do something on YouTube? Anybody? Oh man, this is gonna be boring. If you guys never talk to me, this is gonna be really boring. You've never gone to YouTube to learn something? And I'm not talking about math or even academics. Anything. Help me out with your name. Amanda, what have you gone to YouTube to learn?
Crocheting.
Ah, nice. How successful was that?
Pretty good.
Yeah?
Got it on the back right now.
Nice. All right, so Amanda has learned crocheting on YouTube. Amanda, did you just pick out one video, let it play from start to finish, and then turn the computer off and pick up and do just fine on crocheting? No. Can you walk me through, how did you watch a YouTube video? How did you do that? What did that look like?
Well, I picked whatever I wanted to, crocheting and everything, and then in the beginning I watched a little bit, I paused the video, I did it, and if I messed up I went back in the video and redid it.
Love it, right? I mean, it doesn't matter what you do. Like I looked up on a video or on YouTube last year how to change the headlight in my vehicle because I refuse to pay $50 for somebody to change the headlight in mine when I can do it myself for the price of a light bulb. Okay, I'm totally a DIYer if I can. I'll save money at any cost. And so what did I do? Okay, so I watched the whole video. Okay, yep, I got it. Okay, so let's go out to the car then. I think I can do this. So I go back to the beginning, rewind, back to the beginning, and I push play. What? Rewind. Okay, pause. Go to the car. All right, I can do that much. All right, play. Rewinds. Rewinds. What? Oh, okay, I got it. Pause. Right? Go fix it. So that's how you watch a YouTube video when you're actually trying to learn something. If you're taking the time at home to watch my videos or wherever you might be, if all you do is push play and totally ignore it, hello, you're not gonna get anything out of my videos. You watch a video the same way as when you want to learn something. Now, I realize you might not want to learn Math 110. Guess what? If you're gonna get out of this class, you gotta change that out. You got to. It has nothing to do with whether you want to or not. You need to, okay? So in my math videos, you should be, all right, let's pause, write down what she said. What did she say? Rewind, okay, pause again. And then not only that, after I teach a lesson, I have had students say, Ms. Roberts, when I go back and watch your videos after class, they make so much more sense than they did before class. I'm okay with that. Oh, frankly, it's probably because it's the second time around. Isn't something that's heard the second time around automatically easier? It's not that the video got better. It's not that you got smarter. It's just easier to hear something a second time around. It makes more sense. Besides, you've had some examples to back it up. Okay, so those are there so that you can watch them multiple times. You have to watch them before class. You should watch them after class. It will help you, okay? And besides, I put them on YouTube for two reasons. Number one, you can have closed captioning, and it's fairly accurate, okay? I mean, like, YouTube even knew what SOHCAHTOA was. That's for my Math 111 class. What? How'd you know that? There's closed captioning, and the second reason is people can speed me up if they need to. Yes, slow me down if you need to, but if you got it and you just need it as a refresher, put me on 2 times the speed. I do. Okay, so let's jump right in. You see that some of my examples are highlighted. Those are the ones I'm going to target in class. If there's an example that's not highlighted, I'm going to skip over it for sake of time. And then if you need that, then you can come back and ask me about that. All right, so example number 1, write using intervals and graph. Tell me, what kind of notation is example 1 and 2 in right this moment? What's it called?
Set builder.
Set builder. Yep, set builder. Okay, so I like doing the graph first because I think the graph is easier. So I'm just going to go ahead and graph it. We know that we've got a number line. And what's the most important number that we really care about here? -3. The one that's in the problem, right? Now, set builder notation says, okay, here's all of my values. X stands for all of my values. So we've got all of my values such that all of my values are doing what? What are all of my values doing? Wait, what's that symbol? They're greater than or equal to -3. All right, so which direction is greater than? Is it that way or is it that way? Yeah, it's this way, it's to the right, yes? Okay, so I know that I want all the values to the right of -3. All right, the next question. Can I stand on the -3 or can I just get up right next to the -3? I can stand on it. What tells me that I can stand on it? It says it's equal to. And what symbol do we use when I can stand on it? The square bracket, yep. So there's my graph. Now, the reason I like to do the graph first is that the graph and the interval notation look almost identical. The graph and the interval look almost identical. So as you look at this, you have to move from left to right, okay? So here I am, let me see if I can do it this way. I'm down here and there ain't nothing there. None of my values are down here, okay? So I'm at the left and I'm moving my way to the right. What's the first value I'm allowed to work with? The -3. And am I actually allowed to work with that -3? Yeah, so we would say that we're gonna have a square bracket again with a -3 on it. Now I'm allowed to use values after that. I'm allowed to use values. I'm allowed to use values. When do I stop using values? I don't. So what's down there? Say it again. Yeah, thanks. Now, should I put a round or a square on infinity? How come?
Because you don't actually have a number to stop at.
Well, remember that square bracket is for when you can stand on it. If you think you can stand on infinity, just take one more step to the right. And then if you think you reached it, take one more step. You're never gonna get to infinity. It's not gonna happen. Okay, so yeah, it's all infinities are always gonna have a round bracket, round parentheses. Okay, so again, let's go ahead, get ourselves a number line. What are the important numbers on the number line? -5 and -4. Okay, now I like to put my set builder notation in English. Like on the last question, I said that all of my values were greater than or equal to -3. So I said it in English, okay? Let's do the same thing here. Here's all my values. Remember, X means all of my values, okay? Can you just describe where all of my values are? I love that word, in between those two numbers. Okay, so that means that I'm gonna be coloring in between my two numbers. Now let's figure out what kind of symbols to put on my two numbers. What kind of symbol is gonna go on the -5? How come? Yeah, you can't stand on it. How do you know you can't stand on it? I heard it. There's no equal to. All right, and then what kind of symbol do I put for the -4? A bracket, because I can stand on it. It has an equal to symbol there. Okay, now I love doing the graph first because the interval looks exactly like the graph, right? There's just no squiggly. So what does the interval start out looking like? A round? Yeah, and then a comma, right? Because that's what we use in intervals. And then, yeah, and a bracket. Okay. All right, let's go backwards. So this time we're asked to use set builder. Now, what is always gonna be the start of set builder notation? The curly Q bracket, and then what'd you say, Blake? Yep, X such that. That's, I mean, like, guys, I don't even have to understand set builder notation to know that that's a freebie point right there. Okay, I automatically just go ahead and write that down if it's set builder. Now, before I figure out what to write down, let's, in words, in English, describe where all my numbers are. Okay, so I'm looking at my interval here. Can you just, in words, describe where are all the numbers in my set?
Between 2
Yeah,
and
between 2 and 7. Now let's go back in our minds. We just dealt with a between guy, right? So every time we hit the word between, it's always gonna look like this guy right here. Always. Okay, by the way, did you notice that these are only less than symbols? You're never gonna use a greater than symbol with a between, ever, ever. Only less thans. Okay, so let's go then to example 3. I know it's gonna be a between guy, so let's go ahead and put our X in the middle. Your numbers always have to go in order from lesser to greater, so that's gonna be a 2 and a 7. Let's close up our curly Q bracket there. What kind of signs are always used in betweens? Less thans. Now, the only other thing I have to ask is, should one or both of those less thans be less than equal to? Which one? The 2. How come? Because of the square bracket. Yep. Okay. And that was all I was asked to do on that one, was set builder. All right, you take a second, everybody. Write set builder notation for example 4. Okay, so did you start out with a curly Q bracket? Just then did you use an X such that? Okay, so let's put it in words before we decide to write it down. Where are all the numbers in my set? Yeah, so basically anything, what's the mathematical term that we would use there? Which numbers, all right, let me ask an easier question. On which side of 3 am I using all my numbers? This side or this side? If I'm the 3, everything this way or everything this way? Okay, yeah, everything to the right, yes? What kind of numbers go to the right?
positive.
Oh, okay, so you're kind of right, but I mean, like, all right, rabbit trail. I mean, what if I had -10? There are negative numbers to the right of that. Okay, yeah, what's that word?
Greater.
No, I mean, but yes. Greater than. Yeah, that's the one. Good. Okay, so yes, all of my numbers are to the right of 3. All of my numbers are increasing after 3. All of my numbers are that way. Okay, but let's use math terms. All of my numbers are greater than 3. Okay, so remember X means all of my numbers. Okay, and so we're gonna have greater than 3. Do I need a greater than or do I need a greater than equal to? Just a plain old greater than. It's a parentheses.
It's not always going to be greater, like if it looks like that.
Mm-mm.
It could be.
Woody, wait.
Can that set?
What?
Less than 2.
Mm-hmm. Only set builder will only use less thans only. That was the wrong words. Only between inside of set builder uses less thans. Okay. Everybody else can use anything. And for the record, let me just throw this out there. If you have an infinity, you don't use between. Like maybe some of you are thinking, well, all of my numbers are between 3 and infinity. And although that's a true statement, you never use the word between with an infinity. You only use the word between with 2 numbers, okay? Actual numbers that you can see, that you can stand on, okay? All right, last one. Again, we're supposed to go with set builder notation here. Okay, so we'll do this one quickly. We've got X such that. Can you put into words a description of this picture? Where are all of your numbers? Between, there's that word again, between 0 and 8. So here's all my numbers, that X. Let's put my 0 and my 8 on either side so that my X is between the 2. And what symbols will go in there? Less thans. Do either of them need to be a less than equal to? No, they're both just less thans. Okay. All right. So here's some more stuff that you had from your videos. D and R means domain and range, and I will use that all semester. Okay. So D and R, that's what that means. Find the domain and range, and then also tell whether or not it's a function. Okay, so this is all going back to that video. Again, if you just push play on the video, but you didn't really take the time to digest information, this might be a little confusing. Okay, you have to take the time to digest the information. Okay, so for number 6, let's get the domain first. What's in my domain? 0 and 1. Now, is that like an infinite number of things, or is that just a few things? A few. So then we're just going to use listing notation. Remember, listing notation is what we use when there's only a few things. Okay, so we'll just say that we have 0 and 1 in my domain. Now guys, you say, well, why didn't you put 0, 1, and 0? Well, once it's in the set, it's in the set. You don't have to tell me multiple times that it's in the set. Okay, you might drive your car 3 times a day, but if I say, what kind of car do you drive? You're not gonna tell me a Nissan Sentra, a Nissan Sentra, and a Nissan Sentra, right? You're just gonna tell me you drive a Nissan Sentra, because even if you drove it 3 times in one day, it's still just one car. Okay, same concept. 0's in the set, it's in the set, even if it's used more than one time. How about my range? Okay, I'm actually gonna go a little different. You're correct, Justin. You're correct. Okay, I'm gonna write 5, 3, and -4 just to bug people. Okay, the nice thing about listing notation, it's the only notation that doesn't have to be in order. Every other notation has to be in order. But listing notation is the one notation and it just doesn't matter. Okay. And then the last question, is it a function, yes or no? Now, I defined for you what a function was, and I defined it in 2 ways, okay? What is one of the ways that I defined function? Go back and look. What's one of the ways that I defined function? No repeating x values. And what's the second way that I defined function? Say it again. We can use the vertical line test. So maybe I did it 3 ways. There's one more that I'm looking for. I assume that you're looking at your video notes, and this is for Zoom people as well, not just in-class people. What's the other way that you can define a function? There was only 2? All right. Left to right. Write that down. Left to right. Left to right. Okay. Left to right. You know what? I'm going crazy. Erase that. I'm asking one question and answering a different question in my brain. Just scratch everything I just said. Don't worry about it. Okay? That's fine. Okay, so that's not function, that's domain. Left or right is domain. Okay, so I was still on my domain question there. Is this a function, yes or no? No, why? Yeah, I have a repeating X value. Okay, how about number 7? What's my domain?
1,
Yeah, just 1. What's my range?
12, 13, 14, 15.
Yeah, can I write it like this? Can I write my range like that? No.
Oh.
Oh, yes. Oh, which one is it? No, why not? Is that only 12 and 15? Yeah, the way I wrote it. Is that only 12 and 15? What do you say, Mary Alice? You're disagreeing. What is this? What is, let me circle it so people on screen can see it. What is this right here?
12
It
and
isn't
15.
listing notation, no.
That's 7.
Right, it's just not listed.
So it is right? Okay. Taylor, you said no. Why did you say no?
Because it doesn't tell you everything that's in the question. It just tells you those 2 are in the question, but there's more things in there.
All right. Anybody else? Yeah, go ahead.
I think it's right because
Is it Sierra? Yay! Go ahead, Sierra. You think it's right because?
it's using interval notation, it uses 2 numbers, but it's still the same.
Okay, so it's using interval notation. Okay, so she feels like it's right as well. Anybody wants to disagree? Zoom people want to disagree? We had this discussion at the, yeah, go ahead. Go ahead. Nicely done, Mackenzie. No, oh, you're Mackenzie, right? I kept thinking she's Mackenzie. Hang on, Jada. No, okay, sorry. Can you repeat that? Because I actually really wasn't listening to you. I was racking my brain to remember what your name was.
I disagree because would not mean that it's everything between 12 and 15 and not just.
What do you guys think?
I think she's right.
Yeah, she's so right. She's so right. Yeah, it's interval notation. This is 12, 12.1, 12.01, 12.001, 12.0001. I haven't even gotten to 12.2 yet. Right? How many are in this set that I wrote down? An infinite number. How many are in the range of this guy? Yes, they are not the same thing. Uh-huh. We use listing notation when there's only a few. We use interval and set builder when there's an infinite number. So let's list them out then. What are they? Okay, function or not?
Yes. No.
Do you have repeating X values?
Yeah.
Okay, it's not a function. Not a function. All right, look at number 8. Questions like number 8 are probably one of the most common domain and range questions in the course. If this is one that you struggle with, let me tell you, you better dive in and get a good grasp of this, because we are going to hit this day in and day out. This is big. I mean, it's easy to get domain and range when I'm just listing some things. Okay, when I have to look at a picture, this is a whole different ballgame. Okay, so on the video, what I did, and if you've printed your notes, it's easier to do this. But on the video, what I did was I showed you a little picture of 2 pieces of paper that were coming side by side, right? Domain is lefts and rights. Okay, so I was closing in on it side by side. Okay, remember the range picture was the one that was closing in on the top and the bottom. Okay, so let's just deal with domain for the time being. Where does domain begin? On the left, right? Left, right? No. At the left, correct? Okay, so domain always begins on the left. All right, so I'm as far left as I can get. Now I gotta look at that. By the way, that's called a parabola, a quadratic. Chapter 3 is nothing but quadratics. The entire chapter. Okay, yes, I saw that snarl. Okay, so my question is, a parabola is something that, yes, it goes down forever and ever. In this case, but I don't care about downs. I care about lefts and rights. So right now, if you're thinking downs, throw that out of your minds. I'm not talking downs, I'm talking lefts and rights. So my question is, a parabola, yeah, I know it's going down forever, but what's it doing side to side? Is it just like leveling out? What's it doing? It's getting wider and wider and wider and wider and wider. Okay, it might be doing that slowly, but it is getting wider. Okay, so then what's the x value that's the farthest to the left that's being used on this picture? Negative infinity. Now you say, but Miss Roberts, I only see like it's up to, maybe -5. Remember, it's getting wider and wider and wider. So just because my paper's not big enough to show that, it's still getting wider. Okay, so negative infinity is the farthest x value to the left that's being used. To the left. All right, so my domain starts at negative infinity. Now ask yourself the same question. As we start making our journey from left to right, what's the last x value that's being used all the way on the right? Positive infinity. It never stops using x values. It starts at the very beginning of time using x values, and it uses x values forever and ever, amen. Okay, so we're going to go all the way to positive infinity. Now, domain is left to right. What's range? Which one comes first? Yeah, the bottom to top. You always work your way. Think of it this way. You always work your way from the negative side to the positive side. So in domain, we're working from the left, the negative side, to the positive side. In range, we do the same thing. We work our way from the negative side all the way up to the positive side. Okay, so from bottom to top. So then as you look at your picture, what's the bottommost y value that's being used in my picture? Again, negative infinity. What's the top, tippy top y value that I'm using? Am I using the 4? What does that mean? Square bracket. Function or not a function? No, now I can't really talk about x repeats, but I can talk about the vertical line test. Okay, so does this pass the vertical line test? I can't even do it. Let's see what I can do on the screen. All right, so here's my vertical line, and as it moves, do I ever touch my graph in more than one point? No, I don't. Because remember, this never goes completely vertical. It keeps getting wider and wider and wider. Okay, so yeah, it is a function. Vertical line test, is that the only way? No, but it's the easiest way. You can still think about x repeats. I don't have any x repeats. Because if I had an x repeat, think about what the guy above, number 6, would look like. If I had 0, 5, that would be right here. If I had 0, -4, that would be around here somewhere, right? And you see how vertical line test would hit both of those values at the same time, but they're x repeats. Okay, so one would be directly over the other one. And since I don't have anything directly over in the blue graph, that's, yeah. Okay, I'm gonna skip number 9, it's not highlighted. Let's go to number 11, please. All right, now I'm tired of talking. My voice is starting to hurt. I always get teacher voice the first couple days of class. Get a sore throat. So I want you to do number 11. Do number 11 on your own. When you do number 11 on your own, those of you who are on Zoom, I think there's a chat function, right? Do you have a chat function on your computer? Chat what the answer is. And for those of you who are here, what I want you guys to do is just look to the person around you. Don't get close. We're social distancing. So look at the person around you, see if they got the same thing you did. If you've got it, go ahead, look around, see if somebody else has it done as well. And just chat them up, see what they got. By the way, what are you doing with that x equals 3 piece? What are you doing with that?
Plugging it into all the x's.
Yeah, you're plugging it in. You're plugging it in, okay, for all the x's. Now, don't be afraid of your peers. Remember, you're all here because you don't know what you're doing. And this is a time that it's okay to make mistakes. All right, David, Justin, do you guys get the same thing? Okay, you get the same thing as Sierra? So working on it. Blake, do you have it?
I have the same thing as.
You got the same thing as Blake did? Okay. Taylor? Nobody? Why? Are you scared of everybody in the class? Check with Marshall. Okay, so if you're not sure, then talk to each other about what you did. Well, you're plugging it and then you're chugging, you're simplifying. But yes, plug and chug. All right, so I've got some answers here. It looks like I've got 6 in the chat. Let's see what we've got. So I have 0, 0, 0, 0, 0, and 0. Oh, okay, so everybody on Zoom got 0. Did you guys all get 0? Yeah. Okay, no. So some of you got 0. What else did some of you get? Negative 18. All right. Well, we got to satisfy this because one nice thing about math, it's not like an English essay where, you know, I like you and so you get a good grade. If I don't like you, no, I'm not saying English do that. They don't do that. But at least in math, it doesn't matter if I like you or not. And for the record, I don't even know you well enough to know if I like you or not. But it doesn't matter because math is right or it's wrong. There's no way that the answer can be 0 and negative 18. One of them has to be, maybe both of them might be wrong. Who knows? Let's find out. All right, so here we are. You told me that x equals 3 meant that I should plug and chug, right? I should plug in 3 for all of the x's. All right, so that means that I would have f of negative 3 is equal to negative, and what goes in for x? 3, and then a squared, right? Minus, what goes in for x? A 3, and then a minus, and then a 6. Okay. What's wrong, Devin? Go ahead, ask. It's
Why
fine.
is it f of -3 but x equals 3?
Sorry, it's not.
Okay.
It isn't. That's my bad. Hey, look, you just saw me make a mistake. And I'm not crawling into a hole in embarrassment. And I don't like making mistakes in front of you, for the record. But I'm okay with that. Okay? I'm a human being and so are you. But thank you. I want you to correct me, for the record. Sometimes I'll make a mistake on purpose to see if you will say something. That's not the case this time. I'd love to tell you it was. It's not the case. Okay? But sometimes I will do that just to see if you'll say something. We're not perfect, Justin. That's what I'm trying to tell you. This is an okay place to be making mistakes. Mistakes are something that we should embrace because this is where we're learning. Okay? Now, if I was teaching another 110 today, I can guarantee you I wouldn't make that same mistake today. But I'm not. So, you guys are the ones that have to stick with my mistakes. Oh well. All right. So here we go. Order of operations. What comes first? Parentheses. Okay, don't have any of those. What comes next? Exponents. So let's take care of the exponents. All right, and this is in 3 different terms. So as I look at my terms, here's my first term. So when I simplify my first term, what do I get? Okay, so we have some varying opinions, and I have a feeling this is why we have varying answers. Is it 9 or is it -9?
9. Because it's multiplying 2 negative.
Multiply negative by negative.
It's 9.
Positive.
And
You just did the exponent in b3 squared, and then you multiply that by the negative.
Varying opinions. Oh dear, oh dear, oh dear. What are we gonna do? All right, now I'm gonna turn you guys around so that you can see these 3 ladies right here. I have to use this row because I need more than one. I need more than 2 people. Okay, so Mary Alice, can you wave? Okay, can those of you on Zoom, can you see Mary Alice?
No.
Can you wave again, Mary Alice? Can you see her now?
You're sharing your screen, so we
I'm
can
sharing
see.
the screen. You can't see anybody?
No, ma'am.
Oh,
Take
here
it
all the
out
time.
of the full screen mode and you can see multiple screens.
Yes. What is the button that you push?
Exit full screen. I
Yeah.
think, and you can see other people.
Yeah, you should be able to see people. All this time I thought you could see me. So exit full screen is one way that you can do it. Gallery view is another way that you can do it. I'll have to look. Are you guys able to see the class now? But this is visual. You gotta see what I'm doing. If you can't see what I do next, you're gonna still be clueless.
See your screen, we just can't see any people.
Yeah, I see your iPad.
Say that again, Brianna.
I see your iPad.
November, can you see the people in the class? You're on mute.
Yes, I can.
You can. November, can you tell us again how you're able to see the people in the class and the iPad screen?
So you at the top where those arrows are, you just exit out of full screen mode and you can see everyone else's webcam.
What about on the phone? Is that on the phone or is that on the computer?
I'm on the laptop. I've never done it on my phone before.
The phone, you can only see one screen.
So people in class are saying on the phone you can only see one screen.
I think you can choose which one.
Yeah, you can choose.
I don't know, guys. Becca, are you wanting to say something? You're on mute.
I was just trying to figure it out, but now I got it.
You did get it? You were able to see the people?
Yeah, I can see people now.
Yay. Abigail, are you able to see the people? Abigail, you're on mute. Are you able to see the people, Abigail? Abigail, hello. Okay, moving on, Abigail. Either you're not saying anything, or I can't see what you're saying because you have a mask on. but you're on mute. I can't hear you. Ah, there we go. Abigail.
My
Can you see-
computer was fuzzy for a second.
Gotcha. Can you see
Yeah.
the people, Abigail?
Yes, ma'am.
Okay, good. Brianna, did you figure out how to see the people?
She said to take it out of full screen mode, and I am, but I still see nothing but
At
your.
the screen, Brianna, do you have a screen view option or something?
No, ma'am, I've clicked everything.
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 Do you have, and you don't have a view options at the top?
No, ma'am.
Hold your cursor. Can you move your cursor towards the top? Is there a green box that says you are viewing Melanie Roberts' screen?
Yes.
And then right next to it, there's not a view options?
Yes, but it only gives me the option to fit to window or original size, and I've clicked both of them.
There's not a side-by-side mode?
No, ma'am.
There's arrows up at the top by like the little, like our windows, and if you just scroll, if they're side by side, and if you just scroll to top to bottom, you can come across like her window.
They're
If that
trying,
makes sense.
like, she wants us to see
The
the whole classroom, but I can't figure out. She's wanting me to, but I've tried everything. Do you know how to do it?
Hang on a second.
So this is something really seeing as her teacher. Like what program?
Zoom.
Oh, Zoom. Okay. Tell her you're gonna go out and come back in. I can.
Oh, don't worry about that. Don't do that. I don't want to lose you that long.
She said no. Yeah. You're talking to me, right, Miss Roberts?
I am, Brianna, yes. So Brianna, we'll do the best that we can. You'll just have to listen really carefully, and I'll try to be good with my words to explain what I'm talking about.
Okay.
Okay, and Brianna, you might even, in the margin of your paper, you might want to draw what I'm talking about even, because it's like where people are placed in the classroom, okay?
Okay.
All right, so I have 3 people in a row here. I've got Mary Alice at the back. So Mary Alice, now that people can see you, can you wave at everybody? All right, and then I have Devin who's sitting in front of her, so Devin's waving, and then I have Mackenzie who's sitting in front of Devin. Okay, all right, so here's my question. We're focused on Mary Alice right now. So Mary Alice, can you just put your hand up in the air? Okay, so we're focused on Mary Alice. And my question to you is Devin sitting in front of Mary Alice? Yes, okay. Is Mackenzie sitting in front of Mary Alice? Yes. All right, here's the next question. Is Devin sitting directly in front of Mary Alice? Devin's not? Next question. Is Mackenzie sitting directly in front of Mary Alice? No. See, Devin's the only one, don't do this, Mary Alice, but Devin's the only one who could get slapped by Mary Alice. She's close enough to get slapped by Mary Alice, and Mary Alice isn't going to do that. Right? So here's the deal. Mathematically, let me turn you back around here. Mathematically, do you see my power? The exponent? What is directly in front of that power? Only the 3, right? That is the only thing. Now, is the negative in front of the power? Yes, but is it directly in front of the power? No. So the negative isn't close enough to be slapped by the power. Right? What some of you are thinking of this. All right, do you see the power now? What's directly in front of the power now? No, a parentheses. That's what's directly. That means the entire parentheses can be slapped by the power and whatever's in it, right? So in this particular case, yeah, it's a negative and a 3 that's being squared. But in this case, what's the only thing being affected by the power? Only the 3 is being affected by the power because only the 3 is close enough to get slapped by the power. The negative's out front somewhere, but it's not close enough. It's the Mackenzie. It's not close enough to get slapped by the power. Okay, so let's try this again. What does my first term give me when I simplify it? -9. I have 1 negative and I have 2 3s. Because the 1 negative is too far away from the power to be affected by the power. All right, so then we'll finish this up quickly and we get -18. So for those of you who had a -18, you can say whoop whoop. And for those of you who had the 0, say, okay, so I made a mistake. Let's not make that mistake again. Not a big deal, right? Okay, any questions on that? I got 6 minutes. I just a couple more questions. Any questions? All right. Example 12. This is one of those questions that's so stinking easy that people miss it. Have you ever run into those questions? Like you get to it and you're like, okay, I don't know what she wants me to do because what I think she wants me to do is way too easy. There's no way that's what it is. This is one of those. Okay. So notice that it says f of 3 equals -9.7. F of 3 equals -9.7. Okay, now look at what it asks us to do. Identify a point on the graph. Now let's talk about points on the graph. How do you label points on the graph? Yeah, with an X and a Y and what goes around them? Parentheses and a comma in between. It kind of looks like interval form. Don't start getting confused. I don't know whose bright idea it was to do the same symbolization there. Okay. But a point on the graph uses parentheses with 2 numbers inside. The first one is my X piece, the second one is my Y. Right? Okay, so I'm being asked for a point on the graph. Meaning I need to have parentheses, and I need to have an X piece, and I need to have a Y piece. Okay, what's my X piece? My X piece? Oh, which one is it? What is our normal notation? It usually says f of,
F of
x. So what's in place of the x? A 3. So that's my x, right? My x piece has been replaced by a 3, right? Okay. What does f of x mean? It means y. Yes, it's a function of x, but it means y. So that whole entire f of x is equal to my y value. So what's my y value?
-9.7.
-9.7. Okay. That's it. That's all you're supposed to do on that. Right? So do you see what I'm saying when I say this is a question that people get stuck on because it's like, surely she wants me to do something else, although I don't know who Shirley is. All right, look at number 13. So this is the same question, only now I'm actually asking you to look at the graph and tell me. This is asking you, go to the graph and find what f of -2 is. Now, -2 is in what place? It's in the x place. F of x, right? So our x piece is -2. So let's go find an x value of -2. Let's see, the x value of -2, there's -1. So here's -2. That's the x value of -2. But what does f of -2, what does that mean? What does f of x mean? Y. So what I'm being asked here is, okay, when the x is -2, what's the y on the blue graph? That's this guy right here, right? And how far up does that go? 5. That's it. Now, couldn't I take what this looks like and pretend it was the last example? Couldn't you make a coordinate out of that? What would the coordinate look like if you did this like the last example? -2, 5 inside of parentheses. Hey, isn't that this point right here on my graph, -2, 5? Yeah, okay. Let's do one more here. What's f of 1? F of 1 is 2. Okay. All right. Do you have any questions? Wow, that was good timing. Do you have any questions? Zoom people or in-class people, do you have any questions?